Had a good Christmas break. We're going to start with actually very easy, very short notes this time. So we ended right before we ended December solving matrices. We had 3x3 and 2x2s. And now we're going to learn the application of it. Again, very easy. You're going to use your graphing calculators. If you have them, I'd highly recommend that you get them out while we're doing the notes. So the most practical application we have for using matrices in math is by solving systems of equations. Now you already know how to solve simple two-variable systems of equations, and I know this is probably not one, this is just an example of two variables. So we have x and y, we solve for x and y, and you get an answer. But the problem is it becomes much harder once we start introducing more variables. So you always need the same number of variables as you have equations. So with a two-variable system, you would have two equations. With a three-variable system, which is what we're going to do today, you would have three equations. So we are going to do, this is our example, and we're only going to have one example again because the graphing calculator is going to do most of this for you. So I have this system of three variables and three equations. And we're going to learn how to solve these using the graphing calculators. And note that this process that I'm going to teach you will work for any number of systems. So if you have a 4-variable, 5-variable, 6-variable, it will work for however many numbers you have. You can even go back and use it for 2 variables if you want. The big thing is to make sure that all of your variables are on the same side of the equal sign. If I were to try to solve it with a y equals, it will not work. So here we have this system. Now, what we're going to do is we're going to introduce this as a matrix. So what I want to do is I want to take this idea of the x, y, and z as a single matrix. So the variables are all going to be in their own matrix. And then we're also going to have another matrix that has all the coefficients. So if we look at the first one, the coefficient on the x is 1, the coefficient on the y is -1, and the coefficient on the z is -1. So I have 1, -1, -1. Right? The next one I have 1, 1, 3, and the very last one I have 9, -1, -3. And it's going to equal our answers here, 2, 7, and -1. So once we have this set up as separate systems, this is probably the hardest part. And again, that's not very hard. You put your coefficients in one matrix, and we're going to call this matrix A. We put our variables in another matrix, we're going to call this matrix X. And we put our answers in a third matrix, we're going to call this B. Keep in mind that the variables must be in the same order. If I were to have the x's and y's switched on one of them, or the y's and z's switched on one of them, I'd have to make sure that they're all in the same order. The reason this works is because the order is the way it is. So now that I have this, I can put matrix A into my graphing calculator. I can also put matrix B. We're not going to worry about the X matrix. That's not something we put in our graphing calculator. So you would go ahead and do that, put it in your graphing calculator. Now I want to show you something of how, it's not going to go down any further. Okay, so if I were to take this as variables, A, X, and we know these are all matrices, right, times B. And I were to multiply both sides by the inverse of A. A, -1. And I gotta do it in order. If I don't do it in order, it won't work because it's not commutative. The A and the A -1, okay, inverse times itself gives us the identity, which is 1, or it's the identity matrix, but it essentially comes out to 1. X equals, and I still have this A -1B here. So this would give me this matrix X, Y, Z is equal to whatever the answer is, A -1B. So if I were to, once I put these all in my graphing calculators, now typed in, and keep in mind this is, I just hit the matrix button, right? Typed in matrix A, and then hit the the little inverse key, and I don't have to hit enter yet, times B, it's going to give me a 3 by 1 matrix, which looks like this, 0.65, negative 5.3, and 3.9. And these correspond with X, Y, and Z. So now we've taken what could be a very complicated process, solving a 3 by 3 system of equation, and made it very, very easy. So I want to go back really quick and make sure I talk through this with you one more time of how to actually do this. So I'm given a system of equations. I split it up into 3 matrices. I have a coefficient matrices, all my coefficients, all my variables. I have an X matrix, and I have an answer matrix. And then we are going to take the coefficient matrix and find the inverse. Okay, and again, we don't have to push enter. We can do this all in one step. Okay, so we're going to push times the answer matrix, and that will give me my X, Y, and Z for this. So your homework is out of the book tonight, but they are fairly simple questions. They're all straightforward. They're all written in the right form. Some of the variables might be mixed up, but make sure you have them all in the right order. Put them in your graphing calculators and give me an answer. I do not expect work on this. I do want to see your coefficient matrix. I want to see this written down on your paper for each problem, and then everything else can be done in the graphing calculator.